Hello viewers, here's an interesting question for you picked from GATE 2011. Let me read it out for you once. If the unit step response of a network is 1 minus e power minus alpha t, then its unit impulse response is what? Trust me guys, solving this problem doesn't even take 5 seconds. But the concept behind the problem is very important. So let's dive into the concept first. The concept is any signal can be represented as sum of shifted and scaled versions of unit impulse signal, that is del of n or del of t. This is for continuous time, this is for discrete time. Here's the unit impulse signal. Have a look at this example x of n. At t is equal to 0, the value is 1. This is same as 1 multiplied by del of n. At t is equal to 1, the value is 2. This is same as 2 multiplied by del of n minus 1, shifted to the right by 1 unit and scaled by 2 units. At t is equal to 2, the value is 1. This is same as 1 multiplied by del of n minus 2, shifted to the right by 2 units. By summing all these three, we get x of n. X of n is equal to del of n plus 2 del of n minus 1 plus del of n minus 2. Let's look at another example, unit step sequence. At t is equal to 0, the value is 1, that is del of n, plus at t is equal to 1, the value is 1, that is del of n minus 1, plus so on. By summing all these terms, we get u of n is equal to summation sum k is equal to 0 to n del of n minus k. This is for discrete time. For continuous time, this summation becomes integration. Therefore, u of t is equal to integral 0 to t del of t minus t dt. Here the variable of integration is capital T. Similarly, for unit impulse signal, del of n is equal to first difference of the unit step function, that is u of n minus u of n minus 1. This is for discrete time. For continuous time, this first difference becomes derivative, that is d by dt. Therefore, del of t is equal to d by dt of u of t. The things I explained you just before forms a great base to the concept called convolution. Let's see what it is. Consider an LTI system which is fed with the input, the unit impulse. Then the output it produces is called as unit impulse response, that is denoted by h of n. As this is time invariant system, if the input is time shifted, then the output is also shifted in time by the same amount. If the input is multiplied with some constant k, then the output is also multiplied with the same constant k. Since the system is linear, therefore it follows homogeneity. By knowing this unit impulse response, you can construct output to any of the input given to this LTI system. But how? This is simple. Just shift and scale h of t by the same amount as that of the input. For example, consider an LTI system for which h of n is equal to u of n and some random input x of n as here. Therefore, y of n is del of n becomes u of n plus 2 multiplied by del of n minus 1 becomes u of n minus 1 as stated here, plus 2 multiplied by del of n minus 2 becomes u of n minus 2. So this is the output. The process we use to derive the output is called convolution. Sometimes we use u of n instead of del of n, and the output produced by this LTI system is called as unit step response. It is denoted by s of n. If the input del of t is integrated, then the output of this LTI system is also integrated. As you all know, this is u of t, therefore this should be s of t. If the input u of t is differentiated, then the output of this system is also differentiated. As you all know, this is del of t, therefore this should be h of t. These two relations are important to solve our problem. So that's the concept. Coming back to the problem again, the unit step response is given as 1 minus e power minus alpha t. S of t is equal to 1 minus e power minus alpha t. The unit impulse response is asked. H of t is the differentiation of s of t with respect to time, that is d by dt of 1 minus e power minus alpha t is equal to 0 minus e power minus alpha t into minus alpha, which is alpha e power minus alpha t. It's option A. As I said before, it doesn't take more than 5 seconds to solve.